All right, it's time for our organic nomenclature lesson number 4 about alcohols and aldehydes. You know, like Dr. Jekyll and Mr. Aldehyde, right? Okay. All right, so this is the start of our functional groups. Now, a functional group is there are going to be a few of them that we'll learn, and we'll learn most of them, and which is really just a site of reactivity. So we're not just going too much into like their behaviors or anything. We're just going to look at the sites and just learn how to name them. So the first one is the alcohol, and the way that it will look is you'll have a carbon, and it's got its 3 hydrogens, but it's got an OH group on the end. So that's what an alcohol is. Now an aldehyde, it would help if I used a different color. Now an aldehyde is going to be a terminal one. So it's going to be look like this. You'll have a carbon double bonded to an oxygen with a hydrogen on the end. It specifically has to look like this, and it will always be on the end. All right. So the for an alcohol, its suffix, you know, that thing that comes at the end, is going to be an anol or ol. And then for the aldehyde, its suffix is going to be anal or al. So it can be confusing. They look kind of similar and they have kind of similar names, but so we have to be paying attention for that. So let's just look at some alcohols for now. We'll just do the left side, and we'll take a look at ethanol. So if we have ethanol, and eth meaning 2 carbons, right? So it could look like this, all right? And they come in a lot of different flavors. You could have a ethanol that looks like this. Now, if you really are paying attention, you can tell that these two molecules, there's a separation in between them. These two molecules are exactly the same. Yeah, they are, because these single bonds can actually twist. And if you look at a model of it, I'll show you in class, where they can actually twist around, and this is ethanol is just ethanol. It doesn't matter where that OH group is. That's only because there's so few carbons. Now, if we start adding more carbons, you have to start getting specific about where that OH group is. So, for example, if we're looking at propanol, well, let's add another carbon in here. And the pattern, I mean, we won't get too complicated. Let's look at this one. You can have propanol, and I'm not going to draw my hydrogens because I'm lazy. We'll put the OH group that's on the side, on the middle, right here. Or let's put another one, and we'll do another propanol, and we can put the OH group on the right side. And you might say, oh, well, Mr. Russell, can you put the OH group on the left side? Well, that's the same as this one. Okay. Remember, they can twist around. You're not just looking at one perspective. You have to look from all perspectives. So there's really only 2 possibilities for this. So what we would call this is we would take this, and we would call this one, we would call that one, let's name it, we would call it prop, and 2 all, right? Because it's on the second one, 1, 2, 3. So that OH group is on the second one. Or you could call it 2-propanol. I like to call it 2-propanol. Or sometimes I do the other one. It just depends, I guess. Depends on the mood I'm feeling. And so the other one, it's going to be on the lowest number, right? So it's 1, 2, 3. So that's going to be prop and 1-ol or 1-propanol. All right, and that's pretty much how that one goes. So let's take a look at the aldehydes now. Let's go back, take a look and zoom up at those aldehydes. So let's take a look at this one. If we look at ethanol, that's going to be, nope, I want green, Mr. Russell. I said I would color code them, so I'm going to try. So we want ethanol. So we'll have those hydrogens. I'll go ahead and draw my hydrogens. And so I'll draw my ethanol group, my aldehyde group. So I've got the double bonded to the oxygen and then the hydrogen sitting on the end. Now, if you'll notice that the only way this can actually happen is that if it is terminal. Normally, a lot of times you see it where the aldehyde group is written on the right side, but sometimes it can be written on the left side. It doesn't matter. You can flip it around and it looks the exact same. So it just looks backwards. So it's always terminal. Always terminal functional groups, the fun groups. And now, so let's take a look at the condensed formulas. So for an alcohol, that condensed formula is going to just end in OH. Okay, you just have to show the OH. So let's show this one. Propane 2-ol, that's going to be CH3, CH, OH, CH3. That's the condensed formula. And then for this one, propane 1-ol or 1-propanol, you're going to do CH3, CH2, CH2, OH. All right, very simple. Just add the OH group. Now, it occurred to me that maybe y'all might not see that. A lot of times I just write OH, but that means that there is an oxygen single bonded here and then a single bonded hydrogen here with 2 lone pairs. Okay, that's what that ethanol is actually doing, but chemists like to be lazy and they don't like to write all those lone pairs and stuff. We'll just write OH. Okay, so that hydrogen is still single bonded to the oxygen. I should mention that because that is kind of important. And so the condensed formula for an aldehyde is going to be, I said it was always terminal. The condensed formula, it looks similar to an alcohol, so we have to be able to differentiate in between it. So it's going to be CHO, not COH. Okay? So the condensed formula for this one, for ethanol, is going to be CH3, CHO. If you did propanol, let's go ahead and scroll down just a little bit more. If we did propanol, I forgive my geometry. My geometry is terrible. But if we did this with our hydrogens here, that again, it's on the end. So that would be CH3, CH2, CHO. All right, CHO. All right. And that's going to be it. Pretty sweet, pretty easy. Alcohols and aldehydes.